Okay, so once again, this is Professor Clark. Welcome to our go-to training on graphing and word problems. The first few minutes of class was for, talking and, maybe you guys interacting with each other and seeing if you had any concerns about the class. I'm in the process of recording this session right now. It will be made available tomorrow morning. It takes a while for these sessions to upload once they're recorded. Um, we'll get started. Uh, okay, I see someone talked about screenshot. So I'm going to go ahead and mute everyone at this point. Okay, so everybody's muted. Okay, if you have questions, go ahead and enter them in the chat section. Um, if if you maybe got questions at the end about, the projects or Alex, we can take care of those at the end. But typically, what happens is we cover the lecture stuff first. So I'll talk about graphing and word problems. That'll take about an hour. Then after I go through the PowerPoint, then I will see if anybody has any questions about what we covered in the PowerPoint if you haven't already asked them. And then from there, we'll move on to Alex and the projects. Okay. If you're in here for attendance hours, okay, once all the questions are answered, you'll still need to stick around. Okay. You can go work on Alex or something, stay on mute, as long as you stay in until the entire time. I'm gonna let this go to training out at 6:55 because I got another obligation I got to take care of at 7. So we'll be dismissing at 6:55, and that's primarily for those who have the attendance uh, stuff that needs to be taken care of. We logged in about 4. I started about 4:55 or 4:50, so we'll still have our 2 hours. All right, so I think the screen is available for us. Let me make sure. Yep, the screen is showing. I'm gonna go ahead and close out all these other screens that have surfaced. Let's see. Okay, so they're all out. Can everybody hear me loud and clear? If you can hear me loud and clear, just go ahead and type yes in the chat area. Okay. And I'm going to go ahead and pull up the PowerPoint. First thing we're going to cover is graphing. Okay, graphing is a very important concept. Okay, there are many reasons why we use graphs. Okay, a map is a graph. Another thing that we can say about a graph is that it's a picture, and a picture says 1,000 words. Okay, so the history of graphing, it was used by the Egyptians, the Romans, the Greeks. Every important, powerful civilization known to mankind at their time used graphing. Okay, the graphing system that we know of today that's used in the high schools and middle schools and college came about around the 17th century by a mathematician by the name of Rene Descartes. Okay, it appeared in high school textbooks in the 1900s. Okay, it's important for navigating, which that's what a map is. It's also important for modern warfare, in the sense that we can use it to launch missiles and fire weapons. Okay, you got to have a target. Okay, when we look at a graph, the graphs that we know now, they have vertical axes and horizontal axes. We have independent variables. That's going to be placed on the horizontal axis, which is the axis for x. And we have dependent variables, which will be placed on the vertical axis, which is the axis for y. Okay, and it's dependent because it's dependent upon x. X can be anything you want to, but y is based upon x. So if we have x plus 3, And if x is 5, then 5 plus 3 means y has to be 8. Okay, here's a correlation for us to draw between. One person can eat 3 pizzas. So that means every person can eat 3 pizzas. We use tables to organize data. Okay, we use graphs, tables. Okay, we'll see tables again in statistics. They're used to organize data, not organize, but summarize data. So that's where we put our information and have it summarized. Okay, so we have 3 different values for x. Okay, so these are 3 different problems, but we're summarizing them all on one table. We have values of 1, 2, and 5 for x, and then we're going to solve for y. Okay, and we can see the 5 minus 2 times y here. So let's look at this for a second. Okay, what we basically did is taking this function right here for y, and we put it right here. The only difference is we took out the x and put in the 1, which the 1 came from the left side, and then we did the math. We're going to do the same thing again using the same expression, 5 minus 2x, taking out the x and putting in a 2 this time, and we find that y becomes 1. And then we do the same thing again, putting in 5. Okay, so we're going to do the same thing for 27 minus 3x. It's going to give us 18. And then we'll come up with 1. And now 9. Okay, so what we're doing is we're taking the expression itself, which is, in this case, it's going to be 27 minus 3x. And then we're taking out the x and placing in the 3. Now, where are the 3, the 5, and the 6 coming from? They're coming from right over here. They're coming from the left. So we're simply putting them in and doing the math. And we're putting them in. Let's see, we're putting them in right here. Okay, so we're really doing 3 problems, and we're summarizing those 3 problems on the table. Okay, how to read a graph. Okay, in this case, let's look at one of the values here. We've got the 4 and the 43. So the 4 is here, and the 43 is about right here somewhere. Okay, I'll put 43 in here. So that's a weird 43, but it's a 43. And here, we can see that's 43, and here 4. Okay, so the point that we plot is where the 4 and the 43 meet up at. And here's more points that we'll plot. Okay, when we look at the x values, either, and I'm going to put an x here so this can be helped understood. The x values can be found all on the horizontal axis, and the y values can be found all on the vertical axis. Okay, we'll have x will be positive in this quadrant. Okay, we can see all our positive values down here. X will be negative in the second quadrant, and Y will be positive. So that means that when we look at our order pairs, this is the values we're going to come up with. Down here, we're going to come up with a negative and a negative. And here we'll come up with a positive and a negative. Okay. Okay, we call this first quadrant 1. Everything's positive here. Quadrant 2, the x's are negative, the y's are positive. Quadrant 3, everything's negative. And quadrant 4. Okay, so when we have two positives, they're going to go in quadrant 1, which is what we have for the first one. Okay, so we can see we go to the right one, up 2. For B, it's going to be also in quadrant 1. We'll go to the right 3 and up 5. Okay, now C is different because it's got a negative value, so we wouldn't be putting anything in quadrant 1 because everything in quadrant 1 is positive on the x and the y axis. Okay, so we're looking for a negative x value, so that's going to all be on the left-hand side. And then we'll be in quadrant 2 because the y value is going to be positive here. D is going to be negative. Okay, once again, when we look at D, we're talking about -3 and -4. And then E is going to be +2 and -1. And F will be 0 for x and 5 for y. And G will be 10 for x and 0 for y. Okay, so that's how we plot points. Okay, so once we find those points, we can plot them. But when we're working with equations, we're not going to find any points up front. What we're going to find is math problems up front. And then what we're going to have to do is solve those math problems. And by solving those math problems, we'll come up with our points, our ordered pairs that we'll have to graph. Now, the first one's going to be real easy because what it's basically saying that whatever x is, y is that as well. So if x is 7, y is 7. If x is 3, y is 3. If x is 2, y is 2. Okay, when you're working with equations, they're nothing more than math sentences that state that two things have the same value. So I implore you to read the sentence, the math sentence, to see if you can make sense of it, before you start moving toward the rules. Math can be solved two ways. It can be solved as a language, and it can be solved as patterns. Okay, so the first step, notice how we put all of these values here to the left where we say we got all, notice how that's 0 and 0, 1 and 1, and 2 and 2, because x and y have the same values. Okay, so here's our ordered pairs pulled straight from the, so let's say the first one here is 0 and 0, right here. Okay, we can kind of see how that's written down here into ordered pairs. And so from there, we just plot the ordered pairs. 0, 0, 1, 1, 2, 2. And then we connect the dots. Oh, here's another one. And this one, x and y are opposites of each other. So if one is positive, the other one will be negative. Okay. Okay, so if x is 3, y will be -3. If x is -5, y will be +5. And how do we know that? Because the problem tells us that y and x are the opposite of each other. That's why we got the negative there. If they were both positive, then they would be equal to each other. If they were both negative, they would be equal to each other. So we're going to put in our values. And right here, see how we say, well, and x is 1, y will be -1. And we'll simply plot the points next. and then we'll graph it. Now here's some important features about graphs. Okay, the slope, which is going to be the pattern that exists between the change in y and the change in x, will tell you whether the graph, the line of the graph will rise or fall. And you'll read it from the left to the right to get that idea. We got four types of graphs, four types of slopes: positive slope, negative slope, zero slope, and undefined slope. Okay, once again, the slope is the change in y over the change in x. Okay, and so here we have a slope. Here it's positive because it's rising. It's rising 4. Moving to the right 2. The slope is going to be 2. Okay, so positive slopes. You can see that going up. Negative slopes going down. Zero slope is flat. Undefined slope is a vertical line. All right, so here's a problem right here for us. Well, when we look at this problem, y equals 3x. Okay, we're going to set up our table so that we can organize the 3 problems that we'll use to find the ordered pairs for x and y. For x, we're going to put in 0, 1, and 2. And then for y, we'll solve. So we put in 0, 1, and 2, and then we'll do the math. It's going to give us 0, 3, and 6 when we do the math. And then that gives us our ordered pairs. Now our slope we can see here is going to be 3. And that's simply from looking at the change in y. We can see that change already right here. From 0 to 3. And that's increasing by 3. And the other one's the x is increasing by 1. All right. So we look at our line like this. Here's another example. We're going to set up our table. The table is a summary of the 3 problems that we're going to use to find our 3 points. Okay. From here, we're going to put in the values 0, 3, and 6. And plug in those values for x. And then we'll plot the points. Okay, and we can see that it's rising by 1 and running by 3. Okay, the larger the absolute value of the slope, the more vertical the line. The smaller the absolute value of the slope, the more horizontal the line. So the closer the line is to 0, the closer the slope is to 0, the more horizontal. The further away from 0 the slope is, the more vertical. Okay, so the slope in y equals 3x is 3. So that's further away from 0. Okay, notice how steep that line is. 1/3, that number is closer to 0. 1/3 is clearly closer to 0. Notice how close that line is to being flat. Okay, I need to take a second. So if you guys give me a second, I'm having some technical difficulties. It's going to take me probably about 30, 40 seconds to resolve those difficulties. And then we're going to continue. So I'm going to stop the recording right now. Okay, guys, I think I got it cleared up. Okay, so continuing. Next thing we're going to look at is y-intercept. That's where the line crosses your y-axis. Okay, in our slope-intercept form, and that's called slope-intercept because it gives you two things. It gives you your slope and it gives you your y-intercept. So it gives you M and it gives you B, which is the y-intercept. Okay, so here's a problem. Y equals x plus 2. Okay, and we can go ahead and put in our values 0, 1, and 2 for x, and then solve for y. And there we go. And our slope's going to be 1 over 1. And here we have another one, y equals negative 1/2 plus 1. Now, I mean, we can do the math on this, but we can also see our slope right here. Okay, and our y-intercept is plus 1. Okay, so right here, okay, see the y-intercept, 0, 1. And see the y, see the slope. Okay, here's another one, y equals negative 3x plus 5. Okay, you guys see if you can figure out what the slope is on this one. Okay, don't all answer at once. That was a joke. Okay, so what do you guys think the slope is? Okay, let's see what we got. Is everybody there? Okay. Well, I'll go ahead and do this one, but you guys need to wake up because the next one I'm going to ask you to do. The slope can be found right here. The slope is negative 3. Okay, and then the y-intercept can be found right here. The y-intercept is 0 and 5. So the slope's going to be negative 3, and then the y-intercept's going to be 5. We can put in the values 0, 1, and 2 for x, and then solve for y. And we can see that our slope is indeed negative 3. And then the y-intercept is 0 and 5, as we stated. That's it. And here's our slope, negative 3, which we see in our equation y equals negative 3x plus 5. Okay, another way to find the slope is we can simply find the slope through the graph. So if we've got a problem here, we went ahead and plotted the points. Okay, we can see we got 1 and 4. I'm going to put that on top, 1 and 4. And 87. Okay, so that's our order pairs. And from here, we just simply connect the dots. And we can see from here. Okay, other types of slopes we'll see. Horizontal lines, slope will be 0. Vertical lines, the slope will be undefined. Anytime we have a horizontal line, it will always be a y equals type of problem. Every time we have a vertical line, it will be x equals type of problem. Okay, so one of the variables that will always be missing when we're working with horizontal and vertical lines. Okay, so if we see this problem, y equals 4, and there's a graph. X equals 4 will be vertical. We can see that the slope is undefined. Okay, so just to wake everybody up, got a video to watch? Okay, some of you guys were saying you couldn't hear anything. You need to make sure you got your volume turned up. Oh, you could hear me, not the video. I don't know why that is. Okay, let's do this. I'll send you the link to the video, and then that way you can listen to it. Okay, so there's the link. If you want to listen to it, feel free to do that. Okay, well, everybody has the link now to it, so you can listen to it at your own leisure. Okay. Okay, so the slope y equals mx plus b gives us the slope and the y-intercept. Okay, so we have a problem like this and we're asked to find the slope. The slope is going to be the number in front of x, 3, and the y-intercept will be the number after x, 5. So here's another problem. The slope is going to be negative 1, 6, and the y-intercept will be 3. And y equals 7x minus 4. Slope will be 7, and the y-intercept will be negative 4. Okay, so here's a problem. Okay, in this problem right here, in y equals 2/3 x plus 4. Okay, folks, what is the slope? Okay, thank you, Alan and Christopher. Okay, any other input? Okay, so we see the slope is 2/3, and then the y-intercept will be 4, or 0, 4. And we can use that slope of 2/3 to move over to the right 3 units and move up 2 units to grab the next point. Okay, here's another one. Y equals negative 3x plus 5. Slope is going to be in front, negative 3. The y-intercept will be behind at 0, 5. And then we grab our points. And here's another one. Y equals negative 1x minus 2. And in this case, the slope is going to be silent, negative 1. And y-intercept will be negative 2. Okay, so sometimes we might have to change the slope-intercept form. When the problem's written in standard form like this, negative 8x plus 2y equals negative 16. Okay, so when we want to write in slope-intercept form, we'll simply solve for y. That means we'll get rid of the negative 8x and get rid of the 2. Get y by itself. So we're going to add 8x to both sides. And then we're going to divide 2 from both sides. So that's going to give us y equals 8x minus 16. And then we'll divide both sides by 2. And our final answer will be y equals 4x minus 8. And here's another problem. Negative 13x plus 17y equals 9. From here, we'll add 13x to both sides. Divide 17 on both sides. And then that's going to give us y equals 9 over 17 plus 13x over 17. We'll put the 13x over 17 up front. So we're simply going to take this one and move it up front. And take this one and move it to the back side. Like that, we'll just switch the order of them. And because it's addition, it's commutative, we can do that all the time. Okay, here's another type of problem we'll see. Here we got a system of linear equations. It says a landscaping company places 2 orders with a nursery. The first order was for 13 bushes and 4 trees and totaled $487. The second order was for 6 bushes and 2 trees and totaled $232. The bills do not list the per item price. What were the cost of 1 bush and 1 tree? So the bushes will cost X unknown dollars, and the trees will cost Y unknown dollars simply because they're different. We don't know what the money amount is. So here's our problem: 13x plus 4y equals 487 for the first one. 6x plus 2y equals $232 for the second one. Okay, and that's the way we go about solving it. I think there's another video back here, but I don't want to play it. I'll send you the link. It's a website. But I'm not gonna play this. I'll work with it, so we're gonna copy it and send that link to you guys. So there's a link if you want to play with it yourself. Okay, so shut it down. Okay. Now first eliminate one variable. Okay, so this can be elimination method. Okay, now the way to do that, we'll figure out which one we're going to get rid of. In this case, when we add them together, these two will get eliminated because they're the opposite of each other. One's positive and negative. So that's going to eliminate. We're going to be then 1x plus 1x is going to be 2x. 5 plus 1 is 6. Now we'll solve it by dividing 2 from both sides. It's going to give us what x equals. X equals 3. Now to figure out what y is, we'll just substitute x back in at 3. And then we'll solve for y. It's going to be 2 plus 3 equals 5. And then 3 minus 2 equals 1 when we check it. Okay, so here's another one. On this one, what we'll end up doing is multiplying this whole bottom here by negative 1. And then that will give us these values: negative 2, positive 3, and negative 3. When we multiply, of course, we'll multiply by negative 1. So that's why that's happening. Then we're now able to cancel out the two that are opposite. And that's always the goal, to make one of them a positive and the other one a negative value, same value. So when we do that, that causes one of the variables to cancel out. In this case, the y's cancel out. We're left with 5x minus 2x, and then 12 minus 3. And it gives us 3x equals 9. We'll divide 3 from both sides. X equals 3. We'll plug in. We can take 3 for any value of x. And the first one, we could put a 3 in here. We could put a 3 in here. Or we could put a 3 in here. Well, we'll subtract 15 from both sides. Divide -3 from both sides. Y equals 1. So we check our work by putting in the values for x and y, which we now know that x is 3 and y is 1. Okay, so here's another one. Okay, here we can multiply this one right here by 2. Okay, because this right here, our goal is to come up with 4y. That's our goal. So we'll have a negative 4y to cancel out with a positive 4y up top. Okay, now we can see that we're able to cancel out the y's. And we add the x's and then the constant terms together, the 4 and the 30. Okay, and then that leaves us with 17x equals 34. And then we divide both sides by 17, solving for x. Or we could just say 17 times what will give us 34. That's going to be 2. We'll replace x with 2. And we'll do the math. And we'll end up with y equals 6. Here we're going to have to do a little bit more work. The top has to be multiplied by 3. And the bottom has to be multiplied by -2. And that's so we can get a positive and a negative 6x. Okay. And when we're multiplying by 3, that means everything gets multiplied by 3, not just the 2x, even the 6. We cancel out the x's, then we're left with the y's. 9 minus 8 is 1y. 18 minus 14 is 4. And we substitute in 4 for y and solve for x. So x is going to equal -3 when y equals 4. Okay. Now the addition method of elimination is one way of doing these problems. Another way of doing it is the substitution method. Substitution method looks, I don't know what is going on. Why did it do that? Oh, I was hitting the wrong button, no wonder. Okay, the substitution method is where we have a problem written in slope-intercept form, and we can simply substitute in a value for y or x. So in this case, we can substitute in 2x for y because the equation tells you that y equals 2x. So there we go. So we put the 2x in the place of the y, and then we do our math. 2 times 2 is 4x. Then we combine the two x's to come up with 7x. We divide both sides by 7 and come up with x equals 3. And then we take that value of x and put it back into one of the equations for either x. In this case, we're going to take the easiest one, y equals 2x. We put the 3 in, and that tells us that y equals 6. Okay, here's another one. In this case, we're going to take out the y again. And we're going to put in x minus 3. Then we're going to do the math. Okay, then of course we'll end up distributing 3 times x minus 3. We'll combine the 2x and the 3x. We're going to add 9 to both sides. Divide 5 on both sides. X equals 5. Then we're going to say 5 minus 3 equals 2. On our next problem, x plus 2y equals 10, we're going to, okay, let's see what you were saying, Christopher. When combining like terms, do you work from the left to right? Yeah, we do, but we still have to follow the order of operations, even though we're starting at the left and moving to the right. So that means that the distributive property, where we're multiplying the release parentheses, probably going to happen first. Then we have to combine like terms before we can do anything else. So you always have to follow the order of operations, even though you're all working from left to right. Okay, so in this case, once we substitute in the negative 2x plus 2, notice how we're going to have to distribute the 2 times to the negative 2x plus 2. So it's going to give us negative 4x plus 4. So that means we have to distribute first. And then we'll simply go x. X is going to be 1x. 1x minus 4x will give us negative 3x plus 4 equals 10. We'll subtract 4 from both sides. Negative 3x equals 6. And then we'll divide both sides by negative 3. X equals negative 2. Then we'll take that value of x equals negative 2 and substitute it back into the equation. Okay. And solve for y. And that's going to tell us y equals 6. So those are going to be our ordered pairs, negative 2 and 6. Okay, so here's a word problem involving systems of linear equations. If the sum of two integers is 10 and their difference is 2, find the integers. So the word sum means adding x plus y together to equal 10, and the word difference means subtracting x minus y to equal 2. So here's our equations. X plus y is 10, because the word sum means to add. X minus y equals 2 because the word difference means to subtract. We'll use the elimination method to eliminate the y's. Add the x's together, add the 10 and 2 together, divide both sides by 2. Okay, plug in 6 for x, solve for y, and check our work. Okay, let's do this. We're going to take a 10-minute break. Let's give everybody a chance to use the restroom, unwind, give me a chance to get a glass of water for my throat, and then we'll be back at it in 10 minutes. So let's see what time. Oh, nope, can't do that. All right, so it is 5:52. So we're going to take we'll say an 8-minute break. We'll be back at 6 o'clock. Okay, so everybody can go use the restroom, stretch. We've been at it for almost an hour, and then we'll come back and we'll finish up with the word problems. All right, so I'll see you guys in a minute. I'm going to play a little bit of music while you're just waiting. Okay, folks, welcome back. We're going to go ahead and get started with the second half of our go-to training, which is going to deal with, let's get past all this break time stuff, word problems. I teach on campus as well, so this is the actual PowerPoint that I use for my campus classes as well. Okay, so here's a little icebreaker. It was saying, as I was going to St. Eve's, I met a man with 7 wives. Each wife had 7 sacks. Each sack had 7 cats. Each cat had 7 kittens. Kittens, cats, sacks, wives. How many were going to St. Eve's? Okay, so let's see if you guys can figure out this little brain teaser here. Okay, how many people do you guys think were going to St. Eve's? Or should I say, how many do you guys think was going to St. Eve's? People, kittens, cats, sacks, wives, or others. Okay, Jason says 8 humans. Troy says 1. Elaine says 1. What do you think, Skylar and Leonard? Or is that Leonard? Uh, Skylar and Leonard and Terrence, what do you guys think? How many were going to St. Eve's? Okay. DeAndre says 1. Okay, Skylar says 1. Jason says that is 1 only. Okay. Trevin says it's 1. Okay, I think everybody's pretty much given some input. The correct answer is 1. Okay, only I was going to St. Eve's. Everybody else was just met along the way. Okay, and that kind of gives us a good understanding of word problems. With word problems, you have to read them very carefully. One word or 2 words can make a big difference in the outcome. The word going and the word met distinguishes between the possibility, of 28, 29 going versus 1. Okay, these are some buzzwords that we'll use to denote addition and subtraction. Okay, I would suggest you make your own list. Okay, the words sum and increase by or more than should be on the top of the list. Likewise, for subtraction, the words difference, subtracted from, less than, and take away from should be on the top of that list. You can Google key, you know, uh, math words to get these buzzwords for when to add, subtract, multiply, or divide. Okay, here's multiplication product. One that's not on the list is twice or 3 times. For division, quotient is very important. Okay. Words to denote equality: is, same, are. Inequalities. Oh, kind of scoot back one. Okay. Inequalities. Most important ones are at most and at least, because everything else is taken at face value. At most and at least is not. At most means less than or equal to. At least means greater than or equal to. Mm, I'm hitting it too fast there. All right. I guess I'm going to have to click it because it done no fair. Okay, so here we go. These four are the most important when we're looking at two numbers just being combined: the sum of, the difference, the product, their quotient. Okay, typically what we're getting ready to do is multiply something by their sum, or divide something by their difference, or multiply something by their difference. Okay, the commutative property does not matter when we're adding and multiplying. If we move things around, it won't change the outcome. Subtraction, it does. Subtraction is not commutative. Order matters. And division as well. Okay, so here's a problem: the sum of 6 and 9. Now the and is a locator. It tells you where to place the operation. So that operation sum goes right where the and is. The difference, it's going to be the same thing. I'll do it twice, and then we can just reference it moving forward without circling it. That's going to be 6 subtract x, or n. Now the difference of a number and 6, the and is the locator again. The product of a number and 6. Once again, product means multiply. The multiplication symbol goes where the and is. The quotient of 6 in a number. Okay, the quotient of 6 in a number. The word quotient means to divide. The quotient of the number 6. It also means to divide. We'll divide based upon the order they're written. 7 decreased by a number. Okay, so we're going to subtract. Take away a number from 7. Okay, now when we see those things like take away from, subtract from, I think the other one's less than, then the order of the numbers reverses from the way they're written. So it says 7 less than a number. Even though the 7's first, the order will be reversed and it will be n minus 7. And here's the other one: 7 subtracted from a number. Even though the 7's written first, it will be reversed and the n will come first. So take away from, less than, and subtracted from, the order will be reversed. Lily baked 12 cookies yesterday. She baked n cookies today. Using n, write an expression for the total number of cookies. 12 plus n plus 12. Ted has a bookcase with D shelves. There are 13 books on each shelf. Using D, write an expression for the total number of books. Okay, when we look at a problem like this, that's going to be 13D. There are X chairs in the classroom, 25 of them are occupied. Use X, write an expression for the number of chairs that are not occupied. Okay, so that's X, and 25 of them are occupied. Okay, so we need to write an expression, X minus 25 here. An expression is going to be a collection of numbers and operations, primarily addition, subtraction, multiplication, division, and variables. Okay, the equal sign is not part of an expression because it's not a number, it's not a variable, and it's not a sign of operations. Okay, here's some translating some more words to symbols. Twice their product, 3 times their sum, the difference of 3 times the first number and 3 times the second number. And of course, this is where we're just combining the two terms, the quotient of their sum and their product. The word sum means to add, quotient means to divide, product means to multiply. Okay, so here's another one, the product of 4 and the sum of a number and 3. Okay, so if what we do is if we do this right here, we'll do this in the product. Remember the and is a locator or any variation, anything that looks like and. And then the word sum, which means to add, goes right here. So that's going to be 4 times, open parenthesis, n plus 3, close parenthesis. Okay. And those words and let us know where to put those operations. So you just have to be mindful of that. The difference of a number and 5 is subtracted from 6. And that word subtract from means the order has been reversed. Okay, so that means that the order has been reversed. So we've got that word subtracted from. Okay. And then of course the difference goes here. And so that means these things right here are going to be in parentheses like that. And so the 6 will come back around up front. Okay. And even once we put the difference in here, then that goes back here like that. Okay, because the word difference means to subtract, but that subtraction sign goes where the and is. Because remember, and is a locator. It locates where the operation should go. And of course, we talked about subtracted from, less than, and take away from. All three of those things means that the order gets reversed. And so we're saying we're going to subtract it from 6, so that means the 6 is first. Then those things are on the front end, just like that. Three more than 5 times a number is equal to 23. That word is means equal. Okay. When 4 times an unknown number is subtracted from 31, the result is the unknown. And that word subtracted from, once again, makes the 31 go up to the front. And the word is means equal. Of course, unknown number is x. The sum of a number and 6 is 11. 2 less than a number equals 6. The difference of a number and 11. Now, of course, we know that word difference means that the subtraction goes here. And then, of course, this is an equal sign here where the is is. Is means equal. A number divided by 4 is the sum of a number and 2 is less than 4. All right, once again here, the word sum goes here. And that's an inequality, so we know it's going to be the less than symbol, which looks like that. The difference of a number and 7 is greater than or equal to 11. And so that word difference goes right here. And it's going to be greater than or equal to. We'll be looking at that. 5 times the number is at most 10. Okay, now that word at most does not mean greater than. It means less than or equal to. It means less than or equal to. Okay, here we go. 27 is the product of Jenny's age and 3. Okay, so 27 equals, and then of course that's going to be J3. When an inequality for the following statement, x is greater than or equal to 13. Okay, here's a strategy for solving word problems. Okay, there's a lot of reading there. Okay, the reading is really important. So we're going to put a pin here. There's the word read. There's the word read. There's the word read again. So you want to do a lot of reading. You want to figure out what the unknown values are. You probably want to draw some pictures to get a better understanding of what's going on. You want to follow math rules, the ones that you know, like the ones to solve equations, ones involving fractions and integers. All those rules still have to be solved and followed. Okay, so here's the problem with sales tax. And we have address cost $7, $75.33 after the taxes is added. If the tax is 8%, how much is the dress? Okay, so that's after the taxes. So we got to figure out how much the actual dress really is. Okay, so what we're going to do is we're going to figure out the price of the dress. And then that's going to be X. And then we're going to add the taxes times the price. Okay, and then those two things added together, the price of the dress and then the taxes times the price added together, will equal what the dress costs after tax. Okay, so we'll convert that 8% to a decimal. We're going to add the 1 and the 0.08 together, come up with 1.08. We'll divide both sides by 1.08. And so the dress before taxes will be $69.75. Okay, here's another sales tax problem. Taxable amount of the sales is $70. Sales tax rate is 6%. Sales tax amount. We take the taxable amount, multiply it by the rate, gives us what the tax is, $4.20. We add that to the taxable amount, and that gives us the 74.20. Yeah, 74.20. From there, we'll look at graphs with two phones. If you make 50 minutes of long distance calls for the month, which plan costs the least? Well, it's going to be, for 50 minutes, it's going to be plan A, because we can see that the graph of plan A is below the graph of plan B, all the way up into 250, 50 minutes. And we can see at the bottom with the bottom numbers in the horizontal line. How much less? $8. For what amount of long distance minutes do the two plans cost the same? It's going to be at 250 minutes. The cost spent on long distance is more than this amount. Which plan costs the most? Plan A. And that's because the graph is above the graph of plan B. That's what makes it more. Okay, so since the graph is above, then the price is going to be above too. The graph and actual numbers, they say the same thing. Okay, here's a word problem here. Stephanie bought 10 pounds of salt for $5. How many dollars did she pay per pound of salt? Okay, so that's, okay, so the dollars are going to be first, Then we're going to divide it by the pounds. Okay, the word per means to divide. So we're going to be dollars first. It's going to be the $5. Then we're going to divide it by 10. That gives 50 cents per pound. How many pounds of salt does she receive per dollar? So in this case, since the pounds came before the per and the dollars came after the per, it's going to be dollars per, I'm sorry, not dollars, but pounds per dollar. So that means it'll be 10 divided by 5. And that'll give us 2 pounds per dollar. Marsha drove 320 miles in 8 hours. At the same rate, how many miles would he drive in 24 hours? Okay, so first we got to figure out how many miles can he drive each hour. So it's 320 divided by 8. It's going to be 40 miles per hour. And then we're going to take that 40 miles per hour and multiply by 24. And 24 times 40 going to be 960 miles. Ratios and proportions. Okay, a ratio proportion for 3 to 4 can be represented in the following ways. A ratio proportion is also a division problem and it's a fraction. Okay, now 2 colons is another way of saying 3 to 4. Okay, so here we have a ratio as a percentage. Lisa spent $50 at a grocery store. This amount, she spent $12 on fruit. What percentage of the total did she spend on fruit? That's 12 to 50. We divide 12 by 50, gives us 0.24. Move the decimal 2 places to the right to convert it to a percent. Here's another proportion. Here we don't have to divide. We can cross multiply. 2 times x and 7 times 8. That gives us 2x equals 56. We divide both sides by 2. X equals 28. And here's another one. Irma earns $97 in 4 days. How many days will it take her to earn $485? We'll set that up as 97 over 4 and then 485 over x. Notice how the dollars are both at the top and the days are both at the bottom. 4 days and then the unknown days are both in the denominators. From there we cross multiply. And then we come up with the equation 97x equals 1940. We divide both sides by 97. X equals 20. A tree casts a shadow 28 feet, while a 6-foot post nearby casts a shadow 4 feet. Okay, so we got the actual feet and we got the shadow feet. So that's the way we're going to set up our proportion. Okay. So it's going to be the actual feet will be on top, and then the shadow feet will be on the bottom, 28 and 4. Then we'll cross multiply, 4x, 28 times 6. Going to give us 4x equals 168. We'll divide both sides by 4, and x will equal 42. So the tree is 42 feet. Okay, here's another problem. Okay, this one right here is a DTR problem. DTR problems is distance problems. Okay, with a distance problem, what we're going to simply do is draw a picture looking at the rate, how fast each is going, and where the rest stop is. Okay, and so if we say the 60 miles per hour for the car times the time or times the hours would give us this distance. 60 miles in 3 hours, 60 miles per hour for 3 hours is going to be 180 miles. 60 miles for 4 hours is going to be 240 because it's 60 miles for each hour. So that's why we're going 60 plus 60 plus 60 plus 60, or we can simply say 60 times 4. And the same thing for the motorcycle, 45 times the hours. So we've got 60, we've got 60x and 45x. When we bring them together, we have 105x, and that equals 210 total miles, because that's given to us. Divide both sides by 105. So it's going to take 2 hours. Another one, an airplane takes 8 hours to travel the distance of 6,272 kilometers against the wind. The return trip takes 7 hours with the wind. What is the rate of the plane in still air? What is the rate of the wind? Okay, so we got two different things here going on. We got the speed of the plane and the speed of the wind to make up the rate. So that's going to be x minus y and x plus y. And here's how we break it down. Against the wind, with the wind. Okay, obviously with the wind, it's going to be added. Against, it's going to be taken away. Hours are 8 hours and 7 hours. And the distance is going to be the same, 6,272. Okay, so we can divide 8 from both sides in the first one and divide 7 from both sides in the second one, giving us x minus y equals 784 and x plus y equals 896. We'll cancel out the y's and combine them to come up with 2x equals 1680. Divide both sides by 2. X equals 840. And so we'll take the 840 for x, plug it into our equation, and solve for y. That'll be 56 kilometers an hour. So x is the speed of the plane at 840. Y is the speed of the wind at 56. Okay, so that was just kind of a brief stint into word problems. Didn't spend a lot of time with them because with word problems, we just kind of need a blueprint. We don't really need, you know, there's no one way to solve every word problem. I mean, it just can't be done. You just got to have a blueprint, and you got to think through the problem, read it carefully, draw pictures so you get a full understanding of what they're asking you to do. And then you just got to apply the math rules that order of operations, rules for solving equations, rules for solving systems of equations, okay, rules for working with integers, rules for multiplying, dividing, and subtracting. Okay, at this time, does anybody have any questions about the PowerPoint first, the lecture? And then if no one responds to the lecture, then we're going to move to the next thing. What about the project? Does anybody have any questions about the project? Okay, I'm going to see if I can get in there and okay, so let's see, my recordings. Okay, what about Alex? Anybody has any questions about Alex? Okay, it's not gonna let me record it right now. So once we're finished, I'll record this. You want to punch him? Yeah. Once we're finished, I'm gonna record this session. Typically, when I close out a session, it takes about 30 minutes for the recording to happen. Okay, so what I'll probably do is either I'll record it tonight around 8 or 9-ish. Okay, because I got some other things I got to do after 7. Um, and then I'll upload it to either go to training or upload it to YouTube. Yeah, I mean, let's see. It should be, I want to say quiz three should, it shouldn't be padded together. I think quiz two, no, it should be just quiz two tonight. That's just it. Just quiz two and module two. Because we did quiz one for week one and then we took a spring break. And then now we're in week two here. So yeah, quiz three won't be due regardless of what's being said in FSO. Okay, so if no other questions, feel free to leave. Yeah, that's right, Skylar. The other ones are due later. No, just I want to say module two is due tonight. Then module three will be due next week, the third week. So module two is due tonight. Okay, so you guys, if you don't have any questions, you're free to leave. I'm going to go ahead and stop the recording now. Let's see, recording.